Napoleon, like anyone can even know that.
Hi friends, today we'll be doing something a little bit different but super fun. We're going to be creating a bare bones backdoor connection using nothing but built-in Linux commands. In other words, we'll be following a living off the lands approach to create a very rudimentary C2 connection.
Do the chickens have large talons?
Now what I'll be doing in this video is a slight adaptation of a lesson from the legendary John Strand. Toasty! Now for those of you that didn't know, John, through Anti-Siphon, offers 3 incredible introductory courses that all operate according to a pay-what-you-can scale.
Change!
Now I've done all of them, some of them multiple times, and I highly recommend you check them out, and so I'll put the link right at the top of the description. But even if you don't want to take his courses, John was kind enough to make the labs that he uses in the courses freely available to the public on GitHub. So today specifically we'll be doing the one called Linux CLI, and I'll also provide a link to this lab right at the top of the description. Now I really love this lesson, and the first time I did it, it kind of blew my mind. And it isn't necessarily a lab that has a lot of practical application. You won't necessarily actually be using what we're going to create here as a substitute for an actual C2 framework like Metasploit or Sliver, but it's an awesome lesson that serves kind of as a learning vehicle because it's going to distill what a backdoor connection is down to its most elementary components, which will help us better understand this. And if you're new to Linux command line, it's really going to blow your mind because it's going to show us how certain commands in Linux might work way different than we'd expect them to because of our inherent biases. But methinks right now, it's enough with all this flippin' dilly-dallying, so let's get to it. Right friends, and so you can see here I'm in Ubuntu Linux and I have my terminal open and I have basically 2 instances of the bash shells. Now the bash shell is very ubiquitous, meaning you don't need to run Ubuntu like I am to access it. So you can pretty much also get a bash shell on every single Linux distribution, including Kali. On Windows 11, if you do have WSL2 enabled, you'd also be able to run bash on that. And then I'm not too familiar with the Mac ecosystem, but I do believe that the built-in terminal emulator that you get in OS X, I know the standard is Z shell, but I do believe it already has bash shell installed, or you could probably use something like Homebrew to download it. In any case, I just want to make sure that you understand you do not need Ubuntu to follow along today. You could pretty much do this on any operating system. And so as I mentioned, we basically have 2 different shells open here. And so this one that we're working on now, it's going to kind of represent our victim system, whereas we'll use the other terminal to emulate our attacker system. And now obviously everything is being done on the exact same system here, but that's kind of irrelevant here because in reality, if you ran this on 2 separate systems, exactly like we'll show here, it would work the exact same. And so the very first thing we'll do is we'll run sudo su-, and that's just going to change us into the root user. Right, and so to create this little living off the lands C2 connection, we're going to be running 2 separate commands. So our very first command is going to involve a backpipe. So I just want to make sure that we understand exactly what a backpipe is. Usually when we think of how processes can communicate to each other on the same host, you know, one way in which they could do that is potentially through a network connection on localhost, right? But at the same time, for a number of reasons, it might be undesirable to use an actual network connection to facilitate the communication between 2 processes. And so we can also use something called IPC or inter-process communication files, which are basically a type of file that serve this special function. Now specifically on Linux, this file is called the backpipe. Right, so then let's run the following command. So nothing happens, and of course typically in Linux that's a good sign. So I'm just going to ls quickly, and you can see here actually we have created a file called backpipe, right? So let's just quickly break this command down. Now the mknod command is a built-in Linux command, or a Unix command actually, that's going to create a special file. Now special file is actually the technical term for this file. And what a special file is just a type of file that's, unlike what we typically think of when we think of a file. It doesn't contain any data like text or binary data. Instead, it kind of fulfills some specific function. Now, for those of you that don't have a lot of experience in Linux, well, you're going to require to basically shift your paradigm or understanding of what a file actually is. Because what you think a file is actually a very limited and specific representation of files. Files can actually do and be many things. Now, I'm not going to explain what I mean by this at length here now. However, right at the top of the description, I'm going to share a link to liveoverflow's channel, to a specific video he did called "What is a File Format?" I think in this video, liveoverflow does a much better exploration of what a file is than I'll be able to do, so perhaps consider taking a moment and watching that video first if you feel completely lost. Right, and so moving on, next we have Backpipe. Now Backpipe is simply the name that we chose to give the file here, but of course you could name it anything. And then finally P is where we specify the specific type of file. Now a P stands for named pipe. It's also alternatively called a FIFO, which is an acronym for first in, first out. And so as I said before, we're going to need two different commands. So we just showed the first one, and now we're really going to come to our kind of main course, the actual command. Right, so before we even discussing the actual command, I want to mention that obviously us as Westerners have a left to right bias, meaning we might look at a command like this and we think, well, this happens, and then this happens, and then this happens, and then that happens, and then we're done, right? But Linux doesn't work like that. Computers don't necessarily operate linearly unless we explicitly instruct them to do so. But here, this is not reading left to right. So do your best to just kind of forget what you know or you think you know, and let's just kind of like explore what's going on here. But for now, I think it's useful for us to start with Backpipe, because we already know what Backpipe is. Of course, that is the file, the named pipe, that we created in the previous command, right? So as I said, again, the named pipe, the file Backpipe is really something that is really going to help facilitate communication between two different processes. And we can probably already guess what the processes are, because there are only two processes meant in this command. The first one being bash, and the second one being netcat. And so we can already start guessing that somehow Backpipe is going to be some data proxy, allowing us to move data between bash and netcat. So we start here, we have Backpipe, and it now is redirecting whatever data is inside of it to standard input. Now, if you didn't know, in Linux we have these things called standard streams. There are three: 0, 1, and 2. 0 is standard input, 1 is standard output, and 2 is standard error. Now, if you've never encountered this concept before, it might initially seem weird and complex, but I promise you, once you grok it, it is quite simple. So I've put another video at the top of the description from Learn Linux TV, which is an excellent channel on YouTube, in which he discusses this. So if you feel completely lost and you'd like to know more before advancing, I encourage you to take a quick sojourn, go watch that video and come back. But right again, so here, essentially we're taking the data that is in Backpipe and we're redirecting it to standard input. But standard input of what? Standard input of, maybe you guessed it, bash. So that's a little bit weird, right? Because we'd expect things to move in this direction, but now we're moving in that direction. And the reason we're moving in that direction is because of this symbol. Because this symbol is directing data this way. It is directing data to 0 standard input of bin bash. And so what happens next is quite strange, because we have now our data, it went there and it's here. And now we'd expect it maybe to interact with this again, but this is kind of like a one-way street. It sees that there is a symbol pointing in that direction and it knows it's not supposed to enter that. And so because it sees a one-way street, it's basically going to jump over that and land straight on pipe. And so the next thing that happens is that it'll encounter pipe. And as we know in Linux, pipe will take the output of something and feed it in as the input to something else. And so here specifically, it's going to take the output or the result of what's going on the left here, the green text, and it's going to pipe it in to what's going on to the right, the white text. And this white text, of course, as we can see right now, is a netcat listener that's listening on port 1234. And so essentially, so far, what you can think is happening is there is a netcat listener, right? And it's listening on port 1234. It's trying to receive data there. But because of what we've done here, this is not the only current of input that netcat is receiving. Netcat is also receiving this data right here that we're sending it from the Backpipe. But here now, once again, we see a 1. And so whereas before the 0 represented standard input, our 1 represents standard output. And what do we do with this standard output, the standard output of netcat? Well, we feed it into Backpipe. And then, like I said, the beginning is the end, because now that that data is being fed into Backpipe, it's immediately updated here, meaning it immediately goes again into the standard input of bash and performs this thing over and over. So what is actually going on here? Let's just try and ground this into reality by using an example. Right, so we have this netcat listener that's listening on port 1234, right? Now say on a other system, we connect to port 1234, we connect to netcat, and we give it some data. Let's say we run the whoami command. Well, that whoami command, that data, right, the command, is received, and it's immediately redirected into Backpipe, our named pipe. Right here in Backpipe, I want you just to envision is whoami right now. But now because it's there, it also is there. And now the command is fed into the standard input of bash. In other words, it is as if we are typing or entering or running the whoami command on bash. And so bash will run that command and bash will produce a result, which is of course the name of the current user, in this case root. So now the data is root. And this data will travel, jump over this part, pipe into netcat, and that data will then come back to the person that ran the command on the other shell. And so I'm back in our terminal and I'm literally just going to hit enter and run the command. And the cursor is blinking because, like I said before, this isn't a command that begins and ends. It's just basically folding in on itself and running in a loop. Right, so now that we have that running, we can go to our other shell. Of course, here this kind of represents our attacker system. It represents a different host, a different system. And the first thing we want to do is let's just run IPA. Of course, we want to get our IP address, so I'll copy that. I'll clear. And so here we'll also run netcat to connect to the netcat listener. We'll paste our IP and we'll specify the port of 1234. And we can see the cursor is just blinking, and that actually means that we are successfully now connected to this very rudimentary C2 backdoor. How do we know that? Well, I can run a command and I can get an answer. We can even move around. We can see we're in root now. And now we're in the root directory. Right, and that's it, guys. I just redid this lesson recently and I was very inspired to share it with you because I think it's very unique. I haven't really done anything similar. On one hand, it's deceptively simple because we just ran two commands, neither of which are long, but at the same time, there's kind of a lot of nuance and layers of different things going on here. And I think if you spend your time and really truly understand what's going on here, you'll start to really understand and better intuit some fundamental principles of the Linux operating system as well as backdoors. So I'll be back with another lesson shortly. You won't want to miss it because it will obviously be awesome. But until then,
Peace out.